Alpha Houston on space to ground 1 for Don. We're ready for your downlink.
Okay, I'm going to hit play.
I'm Don Pettit. I was fortunate enough to be science officer on Expedition 6 to the International Space Station. And during this expedition, we had several kinds of science that we did. We did programmatic science, which is well-planned and well-thought-out science, comes up from the ground and is orchestrated from the ground. And then we have science of opportunity. And this is science that is done at the discretion of the scientists on board space station. And this is kind of the discovery science. And during our mission, we called our science of opportunity Saturday morning science. The next experiment you're going to see has to deal with small particles bouncing around, colliding with each other, and coagulating into larger agglomerates. And what you're going to see, basically, a large Ziploc baggie that's puffed up like a pillow. And inside of the baggie, you're going to see particles of sodium chloride, little salt grades. And you'll see several different sizes. Some of them will be 1 millimeter, typical size, and some of them will be larger, maybe 3 to 8 millimeter size sodium chloride crystals bouncing around in this baggie, puffed up like a pillow. And let's look at the fate of these particles as they bounce around inside of this baggie, undergoing collisions with the wall of the baggie and undergoing collisions with themselves, and see if you don't find the result behavior just as amazing as what I found. First, we shake the baggie up, and now we let the particles just float around inside the baggie and collide with each other. And look what happens. They rapidly bump into each other, coalesce, and form these large agglomerates. And here's an agglomerate that's probably 30 millimeters in diameter. And this whole process occurs in tens of seconds. And what we just saw was real time. Now we're going to see the same thing in slow motion. Here we are shaking the bag. We're still shaking the bag vigorously, which breaks up these agglomerates. And now they rapidly form 2, 3, 4 little chain agglomerate particles. And then these, in turn, collide with each other and form these large, fluffy, snowball-type agglomerates that can be centimeters, multiple centimeters in size. Here, we're taking one of these large agglomerates once they're formed, and if we impact it against the side of the baggie at velocities of a centimeter or 2 a second, it just compacts this agglomerate into something that looks kind of like a big snowball. And this shows that these agglomerates, once they form, have a fair amount of cohesiveness. It takes a significant amount of energy to tear these agglomerates apart. And it looks to me like what's happening here. We have electrostatic forces which are bringing these small particles together, around 1 millimeter diameter sodium chloride particles. They rapidly form these agglomerates, and then they have a fair amount of cohesiveness. It takes a fair amount of energy shaking this bag around to tear them back apart down into the individual particles. Now we're going to see a similar system, but these are the large sodium chloride particles. These are 3 millimeters up to 8 millimeters in diameter. And you can see they rapidly come together and form similar agglomerates, just like we saw in the 1 millimeter sodium chloride system. So it seems to be independent of particle size. They will all form these large agglomerate clumps.